In the chat. Those who are removed from Google Classroom is attended or not? Can you please confirm the chat? So yesterday I heard some people are removed from the Google Classroom. Have you checked your Google Classroom? How many people are removed? One, only one. Okay, now you are no problem. Then what about online? So not you are able to join the class, right? Yeah, that is good thing. You're able to join the class. Later you can talk to your management. Yeah, sorry for the delay. Today we started a new batch morning 7:15, but due to winter, no one came. No one came, and this is a very. It's happened in the winter times. It happened in the winter times. In the morning, early morning times. The correct time is 10:30. 10:30 is the correct time in the winter. We'll make one more batch, 10:30 also. Summer morning 7 o'clock batch is good. Winter 10 o'clock, 9 o'clock batch is good. That is. Hey Arun, hi. Yeah, pay the fee, man. Pay the fee, ma. Please complete the fee ASAP as soon as possible, because they will revoke the access completely and you will not join the class also in the future. Okay, pay the fee, that is. Yeah, those who are can't access Google Classroom already paid. Okay, those who are that is there, please contact to Rajeshwari madam. You have a Rajeshwari madam number is there, right? Rajeshwari madam number. Just share the your P receipt P in the group WhatsApp to him. Oh, sorry, WhatsApp to her. Then you will get. Yesterday I also shocked ma, because so many people are removed from the classroom. I checked yesterday after you messaged me. Morning 9 o'clock, right? Morning 9 o'clock. That is the old one. Yeah. 88 are there because our count is more than 100. That means 20 persons are gone. Okay. 20 persons are gone from Google Classroom. Make sure that you are added immediately. That is. Make sure that talk to Rajesh sir here and there Rajeshwari madam. That you know the contact numbers, right? Very good. Yeah, let's come to our sessions. Not this. This. Now, till now we completed these 30 pointers, ma. Can you look at the ones about 30 pointers? What is statistics? Type of statistics, population versus sample, data types, levels of data, parameter versus statistic. Parameter versus statistic, frequency table, frequency distribution table, bar plot, pie chart, histogram, distribution plot, central tendency in that mean median mode, mean versus median. Then we explore about outlier concept, types of distribution, negative skew, positive skew, no skew, and range, mean deviation, absolute mean deviation, variance, standard deviation, how to find the outlier, percentile, quartile, box plot, univariate, bivariate, multivariate, scatter plot, covariance, covariance matrix, correlation, difference between covariance and correlation. Amma. Okay, 30 pointers. So now 30 pointers, you need to write your write up and you need to explain the PPT, and one day exam also is there on this. Exam. Okay. Exam, not that 8 marks exam. I hate to provide the 8 marks exam kind of. It is a multiple choice questions, MCQs. MCQs. In the MCQs, not only you need to provide the ABCDs, you need to provide your answers, explanations. Explanation. Explanation. Explanation you need to write why you are keeping that answer only. Huh? That explanation should be in the 2 lines only. 2 lines, not 20 lines. Okay. It is in the only 2 lines. That's the MCQ exam. Okay. 2 marks question. 2 marks question. But I hope any doubts in this all 30 points? Everyone is good, right? Everyone will be able to explain? Everyone able to explain? Yesterday, some students are saying that of the book is over. Half of the book is over. Statistics very, very important, ma. If half of the book is not over, that means you are not writing properly. Okay. You are not writing that. Yeah. So the ChatGPT is invented by whom, ma? OpenAI. OpenAI is collaborated with? Who is the fundraiser for OpenAI? Microsoft. And the next one is for Google is called Wizardbot, and we also seen about MakerSuit, right? MakerSuit for Google. And what recently for Amazon? 1 week back, Amazon said, Amazon published their product. What is the name of that? I will not talk with you if you do behave like this. What I told you? You need to track the latest technologies and all these things. No? You will not watch the news every day. No news app in your mobile. No news app. Arre. At least download one news app. At least one download news app. There is a one news app is there. I'll tell you what are the news app is there my mobile. InShots. Okay. InShots. Short usage in English. That is it. InShots. Download that InShots. And one more thing, Telugu is there. Eenadu app is there with me. Eenadu app. Telugu. That is. If you are not, if you read at least, yeah, Amazon Q. Amazon Q. Very good, Gaurav. What is Titan? Watch. Amazon Q, ma. What is the name is called? Amazon Q. I told you right before the class. In future, AWS also, Amazon also will implement one generative AI. Now the name is called Amazon Q. What the name is called? Amazon Q. Like ChatGPT, like MakerSuit. Now Amazon Q. Amazon Q is the term. What is Titan? Shravani. Text to image model. Text to image model. Okay. AWS. AWS is a cloud. Sam Altman is only the OpenAI. Is now with OpenAI. That is Amazon Q. Generative AI powered assistants. What is the name is called? Amazon Q. Download one news app. Not like Spotify, not like Wink Music, not that. Okay. Download one app, news app. And at least before going to sleep also, at least open the news. Okay. You will get sleep in 2 minutes. Okay. Get sleep in 2 minutes, that is. Amazon Q. Hey, Venu, how are you? A long time. Amazon Q. Array, my students, I thought very fast, but you are very slow. Not liking this. Not liking this. World is ruling by only 3 companies, right? Microsoft, Google, Amazon. Now, whoever invented, suppose Kumar invented a generative AI, then Amazon will buy the Kumar. Simple. But Kumar will never grow. Like this, that is the scenario, na? They will they will buy the competitors. WhatsApp bought by Facebook, right? Like that. Instagram also Facebook, huh? Instagram also Facebook. Everything is Facebook only. WhatsApp and Twitter, Elon Musk. That is, yeah, it's not Facebook. Let's see now. Let's deal about the some important rule, ma. Important rule that is called empirical rule. The name is called what, ma? Empirical rule. Very, very important question. Empirical rule. Where is Surender? Where happened, Surender? You are not saying the Amazon Q name. You don't know really? Empirical rule. Yeah, Suresh. Yeah, I know. Power cut is there. Even American also struck, right? How many knows American struck in Chennai? How many knows that? That means you're really not watching news. What you are daily doing, guys? America got struck in Chennai. Huh? That is, you don't know about that. We're great. Morning they rescued, yeah. That is very good, great. That only, I confirm that. Either people are playing PUBG or either talking about Big Boss. Big Boss. How many are Big Boss fans? Huh? No Big Boss fans. Really? Should I believe that? No. By the way, Uma Maheshwari, your article is very good, ma. That is your write-up of statistics. It is very good. I like that. Keep it up. Just draw the normal distribution, everyone. Please draw the normal distribution. I strictly want to my wife, no Big Boss in our house. Yeah. I strictly want to her, no Big Boss in our house. That is. I hate the Big Boss. Yeah. Next. It is a normal distribution, ma. The normal distribution. So try to draw the normal distribution and try to draw. It is a mean. It is what, ma? Mu. It is a mean. Mu. Okay. Middle. Mu is nothing but a middle. Correct, money? Suppose here, this is called mu plus 1 sigma. Mu plus, right? It is a mu. It is 50. So it is plus 1 sigma. 1 sigma. And this is mu plus 2 sigma. Mu plus 2 sigma. And this is mu plus 3 sigma. Mu plus 3 sigma. Similarly, this side mu minus 1 sigma, mu minus 1 sigma, and this side mu minus 2 sigma, and this side mu minus 3 sigma. Mu minus 3 sigma. Mu minus 1 sigma, mu plus 1 sigma, mu minus 2 sigma. So generally, mu plus 1 sigma meaning, what we can say that? Mu plus 1 sigma. The mu plus 1 sigma. The meaning is here, here the number of observation between the more than one standard deviations. This is from here to here, from here to here, the distance we measured in the standard deviations, right? This is one standard deviation distance. One standard deviation distance. Suppose here 50 is there. Here 50 is there. Here 60 is there. Here how much is there? 60 is there. There are 10 observations. 10 observations more than one standard deviations. 10 observations more than one standard deviation. And suppose there is a 80 is there. 30 observations are in 2 standard deviation. The distance generally from here to Bangalore to Hyderabad, how much distance? 600 kilometers. Suppose you will say in the kilometers, but in the distribution plot, how can you say the distance? In the kilometer there, here what? Standard deviations. Number of standard deviations is nothing but number of distance metric, that is. In the distribution plot, note on this. In the distribution plot, the distance measure in terms of standard deviations. In terms of standard deviations. Standard deviations. In terms of standard deviations. In terms of standard deviation. The observation is in one standard deviation from the mean. Okay. So mu plus 1 sigma means, so generally 1 sigma means generally any observation, suppose an observation, one standard deviation from mean, 1 kilometer from mean, one standard deviation from mean. Okay, that is the way we can say 1 sigma means an observation, one standard deviation from mean. One standard deviation from mean. Now come to here now. Now this part. Okay. Similarly, so this part, and this part. And similarly, this part. What is the equation of the normal distribution equation? What is the equation? 1 by k. Very good. 1 by k. What k? 1 by root 2 pi sigma square e power minus x minus mu by sigma whole square by 2. This is the equation. Remember? That's the equation. Now this is the entire equation. Now, if I want to find the area between mu minus 1 sigma to mu plus 1 sigma, if I want to know area between these two, This point to this point. Area under the curve. Area under the curve. How can you find the area under the curve? Integration. What is the lower limit? Mu minus 1 sigma. What is the upper limit? Mu plus 1 sigma. How much area is covering? How much area is covering under the normal distribution? What is the normal distribution f of x? How much area is covering from mu minus 1 sigma to mu plus 1 sigma? That means how many observations are falling? How many data? How much data is falling between mu minus 1 sigma to mu plus 1 sigma is called 68% data. How much ma? 68% data. How much data from here to here? 68. 68% of data is fall between here to here. From mu minus sigma to mu plus sigma. That means here to here. 68% of data will fall. It is proved, ma. It is proved. How can you prove? Means that like that this is the scenario. You need to prove like this. From 2 sigma to minus 2 sigma. From here to here. From here to here. This yellow line to yellow line. It is fall with 95%. How much percentage? 95. Every normal distribution. And for 3 to 3. 3 to 3. 99.7. How much is that? 99.7. 99.7. 1 sigma to 1 sigma, how much data ma? 68. 2 sigma to 2 sigma, how much? 95. 3 to 3, how much? 99.7. 99.7. 99.7. 99.7. The percentage of data. The percentage of data. The number of observations or fall between mu minus 1 sigma I'll write like this. Between mu minus 1 sigma. Why it is coming like this? 2 mu plus 1 sigma. Mu plus 1 sigma. I don't know why it is not coming here. How much that is called? 68%. Similarly, two sigma to 2 sigma, 95. 3 sigma to 3 sigma, 99.7. Almost all the observations or maximum fall between which how many distributions ma? 3 to 3. 3 to 3. And this is called empirical rule. What is the name is called? Empirical rule. Don't forget this. Very, very important interview question. Empirical rule. Empirical rule. 68, 95, 99.7. They will write like this. 68, 95, 99.7. 99.7. is a code. The code is for how much data fall between one standard deviation to one standard deviation. One standard deviation. How many people will stay in per 1 kilometer radius, 2 kilometer radius, 3 kilometer radius? Generally, the government will survey, right? The more people are there in the city or less people are there in the village. How can you calculate that? Per 1 kilometer per radius, how many people will stay? If more people are there, means that is a big city. Like that, in 1 sigma to minus 1 sigma, how much data will fall? 68% data. 2 sigma to 2 sigma, how much fall? 95. 3 sigma to 3 sigma, how much? 19.7. And this will valid for only, this is valid for only normal distributions. Normal distribution. I told you, right? All the mass is developed by who, for whom? Normal distributions only. This is valid for only normal distribution. This is valid for only normal distribution. So this is everyone able to say mass 68, 95, 99. If you by heart, you will able to say. But my intention is how you get this value. How you get this value? How you get that value? Every value you will take the area under the curve. How you get the value? By calculating area under the curve. By calculating area under the curve. So our formula, normal distribution formula is suppose f of x, right? Is a f of x. That f of x is your integrate a lower limit to upper limit, then you will get automatically the 68, 95, 99. That we will see in the Python also. Through Python, we will see that. So this you will need to explain in interview. Then only you will become a deviation from other students. Because everyone able to say this. But how you are getting that value? Because tomorrow your interviewer asks you the same approach. Suppose tomorrow one more diagram is like this is there, suppose. It is already there, empirical rules. Okay. Suppose think like that. Tomorrow, a curve is there like this is there. Now, the curve is there. Okay. Now, what is the equation of this curve? It is of BH. What is the equation is called? Of BH. Now, if you integrate of BH from here to this point, then you will get the value of this, right? So that is the meaning. If you know the equation, you can find the area under the curve. If you know the equation, you can find the area under the curve. Like that, you need to be able to explain the interviewer. Then interviewer will know that you know some maths. You know some mathematics. Because in the normal distribution, we know the formula. That's why we are able to identify the percentage of data. Some wherever you have some, the formula is there. Suppose there's a zigzag distribution is there. A distribution is there like this. It is going up, coming like this is there. Do you have a formula for this? No, we can't able to identify the mass for this. Are you getting what I'm saying is? So that's why the math and formula is very, very important. So that's why you know the mathematics, you know the formula, you know how to find the area under the curve. You know how to find the area under the curve. Let's see now. Let's see some use case on this. What is exactly use case of this? This is very, very interesting one. Okay. Use case. Some example, okay. In India, the average petrol rate, how much? 100, 109, In India, the average petrol is 100. 100 rupees. Let us assume that. It will vary by 2 rupees to state to state. State by state. State to state. To state to state. Okay, this is the question. In India, the average petrol rate is how much more? 100 rupees. And it will vary by state to state is how much? 2 rupees. Now, what is the mean here? What is the mean here? The mean equal to 100. Mean equal to how much more? 100. What is the standard deviation here? 2. 2 rupees is the vary, right? Data flow. Data vary, always all nothing but what? Variance and standard deviation. So standard deviation is how much? 2 rupees. Standard deviation is how much? 2 rupees. That is equal to 2 rupees. Now calculate mu minus 1 sigma value and calculate mu plus 1 sigma value. Calculate that. What are the mu minus 1 sigma and mu plus 1 sigma values? Calculate that, everyone. Mu minus 1 sigma equal to 100 minus 1 into 2, comma, mu plus 1 sigma equal to 100 plus 1 into 2. So this value is how much, ma? 98, and this value is how much? 102. Now calculate other three also. Now calculate that. Now 2 sigma, that is equal to 2 here, 2 here, and 96 here, and 104 here, and 3 here, and 3 here, and 3 here, and 3 here, and 94 here, and 106 here. So this point is nothing but 98, 102, 98, 102, and this point is nothing but 96, 104, 96, 104, and this value is nothing but now 94, 106. Everyone is good? Calculated now? Now draw the diagram. Now draw the normal distribution. Draw the normal distribution, everyone. Draw the normal distribution. Now this is mu. That is nothing but 100. This is 100. Correct? And this is 102. This is 102. And this is 104. And this is 106. 106. And this is 98. And this is 96. And 94. Now it is coming like this, like this, like this. Normal distribution not came correctly. Yeah. Array. Not able to draw correctly. It's good. Somewhat. Now this is 94. And this is 96. This is 98. And this is 102. Till exact off should come. 102. And this is 104. And this is 106. 6. Now tell me what is the meaning of these values now. Tell me, you are a business magnate. You want to talk with Satya Nadella about this diagram now. How can you talk with him? Number of states. Tell me exactly. Tell me. Venkatesh, you are saying correct. Petrol vary from 94 to 106. Elaborate that. Say loudly. Not here. Say loudly. I don't know about standard deviation meaning. How many times I told you, right? Okay, don't use the technical words. Tell me. 68% of? Very good. Very good. What is 99% of rate? Not 99% of rate, ma. The meaning is nothing but one standard deviation means how much percentage that you know? 98 to 102 means how much that value? 68%, right? That means in India, 68% of states having petrol rates between 98 to 102 rupees. Correct? In India, 68% of states. So what you can write here? In India, 68% of states has petrol rates between 98 rupees to 102 rupees. That is the meaning of that. This is a way good insight, good data scientist. Similarly, in India, how many percent of states? 95. 95% of states having petrol rates between 96 to 104 rupees. In India, 99.7 states has petrol rates between 94 to 106 rupees. That means almost all the states has petrol rates between what, ma? 94 to 106 rupees. Very rarely you can see in India more than 106 rupees. Very rarely. You can go Karnataka, you can go Bangalore, you can go Chennai, you can go Mumbai. The petrol rates pakka maximum 106 rupees. That is the confident we can get. Very rarely you can see 107 rupees. Very rarely you can see 107. That means all the states, right? 99.7 states. All the states are between 94 to 106 rupees, which means the minimum petrol rate in India is 94 rupees approximately, and the maximum petrol rates in India is 106 rupees approximately. Now, if you present like this, then everyone will be understand, right? What is going on in India about the petrol rates. So this is about the data analysis, ma. Data analysis. Standard deviation you should not use. That is all the things you should not use. That is, you know, technical guy. But how can you explain? Like this, you need to explain, ma. So this is one of the good use case. When I prepare for this IES exam, there is a one material I bought from one institute. The institute they draw this diagram as the front page. This diagram they drawn as a book cover is there, right? General book cover. This is a diagram. I don't know about the diagram meaning at the time. I don't know about the diagram meaning about that. I thought just time pass they draw like this. But later I studied the data science concept. I know about that. Why they drawn this? That is the empirical rule. That is the empirical rule. They're drawn like this. Yeah, very rarely. Correct. Yeah, exactly. That's the outlier. Those who are coming more than now 99 means outlier, because you are charging more rupees for petrol as usual, right? Very rarely petrol can get less than 90 and greater than 100, which considers a outlier. Yes, correct. We can consider that. As usually India saying that 106 rupees maximum, but you are paying that 110 rupees. In the villages, generally they will charge more. 94 rupees is the minimum, but you are giving only 80 rupees, which means it is not a petrol. Water also there in that. That is, these are called outliers. These are called outliers. Very good. Now that's why no. Now this is the reason. What is the outlier now? Tell me outlier formula. What is the outlier formula? How can you find the outliers now? Don't look at your books, ma. Q3 plus 3 into IQR. Why 3 now? Because for 3 standard deviation, how much data is there? 99. That's why 3 is the maximum. That's why not 4. 4 is not there. See? Only 3 is there. 3 into IQR. And one more thing is called Q1 minus. Tell me, what is the formula? Q1 minus 3 into IQR. What is IQR meaning? Interquartile range. Q3 minus Q1. 50% of data is existed in that. Middle class data. So that's why. Now are you getting the interlinking now? Why 3 is there? Why 3 is there? Everything. So this is the empirical rule, ma. This is the empirical rule. And this is developed by scientists, and say the same will tally with using Python code. We'll take some data and we will find the mean, we'll find the standard deviation, we'll get this cutoff value, we'll get this cutoff value also. How many observations are there? We will take number of observations and we'll divide it by total observations. Then we'll get the percentage or not. That we will check. All the quick checks we will do by using Python. All the quick checks we'll do using Python. Don't worry that. 1.5 is a mild outlier. 1.5 is a mild outlier. 1.5 is a mild outlier. 1.5. 1.5. The mild outlier. That only. Whether you want to keep 3, whether you want to keep 1.5, whether you want to keep 2, that is your wish. Your manager wish, ma. But maximum is how much? 3. Maximum is 3. Okay, that is the outlier and is the empirical rule. Now next thing is, what happens if data does not follow normal distribution? What happens if it does not follow normal distribution? That is the next one. You did not opted for recording videos, Shankar? What happens if data does not follow a normal distribution? So there are 2 types of questions, ma. One is, the first answer is, this is come by real-time experience only. This is not there in the textbook. This comes by only real-time experience, those who are working real-time. The first answer is, if data follows not normal distribution, if you know the equation of the data. If you know the equation of the data. If you know the equation of the curve. Equation of the curve or distribution plot of the distribution. Then what you need to take, ma? Area under the curve. Area under the curve is the solution. Area under the curve is the solution. For example, That is suppose, you know, that a triangle, area of triangle, area of triangle. Area of triangle is how much ma? Half into breadth into height. B and H. B and H. Now you know the curve, you know the equation, and you know how to find the area under the curve, right? Area under the curve. And second thing is you doesn't know, that is the zigzag equation. That is the zigzag curve. It is not normal. It is not a very prescribed area under the curve or rhombus or trapezium, or you know what is another thing is called? Rhombus, trapezium, parallelogram. Parallelogram. It is not that kind of equations. Then it is a kind of zigzag. Then the guy is called Chebyshev. The scientist name is called Chebyshev. Chebyshev. Chebyshev inequality. Chebyshev inequality. Or Chebyshev theorem. Chebyshev theorem. Chebyshev theorem. Chebyshev theorem. So instead of mu minus 1 sigma, mu plus 1 sigma, in Chebyshev, the general thing is called K ma. K standard deviations. So instead of 1, what do you write ma? K. You'll write K. From K standard deviations, from 1 standard deviation, 2 standard deviation, 3 standard deviation, in Chebyshev, what we mentioned ma? K standard deviation. For K standard deviations, for K standard deviations, for K standard deviations, the data coverage is equal to 1 minus 1 by K square. 1 minus 1 by K square. 1 minus 1 by K square. Now suppose K is equal to 2. If data not follows normal distribution, and the data coverage between two standard deviations is how much ma? How much? 2 square is equal 1 minus 1 by 4 is equal 3 by 4 is equal 75%. 75% it will cover. When it does not follow normal distribution. It does not follow normal distribution. How much percent will cover ma? 75. If it is follows 95. If it follows how much? What is the rule? 68, 95, 99. Right? 68, 95, 99. But it is not follows normal distribution. How much it is? 75. Now suppose K is equal to 3. Tell me K is equal to 3. Suppose K is equal to 3. If data not follows normal distribution, the data coverage between 3 standard deviation equal to approximately how much ma? 90, yeah? 8 by 9. 9 9s are 81, huh? Approximately 80. Approximately 80. Data does not follows. 4 aito? 15 by 16. 69s are 144. 90%. So it is increasing 5%, 10%, like the slowly is increasing. Suddenly it is increasing 75. After 75, slowly it is increasing, right? Understand the meaning? Suddenly for 2 standard deviation, suddenly 75%. Then 3, only 5%. Then 4, 10%. Even if you take the 5 also, 24 by 25 will come. 24 by 25 means how much will come? How much? 24 by 25. Not even 100%. Again in 90s only. Again is 90s only. Again is 90s only. So now, take a table. Data follows normal distribution, not follows normal distribution. Now 1 standard deviation, 2 standard deviation, 3 standard deviation. And this is not required. The table will write like this. Follows, not follows, 1 standard deviation, 2, 3. This is normal distribution follows. Normal distribution. And this is not normal. Not normal. Who is the scientist? Chebyshev. Chebyshev. And this is what? Empirical. This is what, ma? Empirical. 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 And this is number of standard deviation is equal to 1 and 2 and 3. Number of standard deviations. And this is 68. And this is only is the drawback. It is the only drawback. When k is equal to 1, when k is equal to 1, when k equal to 1, what happened? It is nothing but a 0%. 0% coverage. 0% coverage. 0% coverage is a drawback. It is a drawback. When k is equal to 1, 0% coverage. And 2, nothing but 75%. 68%, 75. Here how? Some 95, no? Here 95. Here what is there? 75. And here 3 is 99.7. And here it is approximately 88.8%. If data follows normal distribution for 2 standard deviations, 95%. If it is not normal for 2 standard deviation, it is 75. 1 minus 1 by k square is the formula. 1 minus 1 by k square. 1 minus 1 by k square. The normal companies, they will ask this question, but in the big companies, they will ask this question. What I observed in my experience. In normal companies, they will ask this question. The big companies, that pakka, they will ask this question. That is. So you need to explain, that is. This is called Chebyshev inequality. When I attended some interviews and note down one company, okay, I will just show you that interview questions. First question is what is standard deviation? It is formula. That is the first question. Everyone able to say? Now say what is the answer? What is standard deviation formula? Say loudly. Say it, no? Say it. Don't know? Under root of 1 by n summation x minus x bar whole square. Pakka. If you don't know, if you don't say, they will not give the job, ma. They will not give the job. What is the second question? Empirical rule. And what is the third question? Okay. And one more question is correlation. One more question is what? 4 questions. If you will be able to say 4 questions now, then interview will be happy. audible, right? You feel like that these are easy questions? Class, 4 questions are there now. 4 questions are easy questions or hard questions? One, tell me, easy question or hard question? One of the old students feel like that. After he learn everything, he feel like that these are bacha questions. Okay. But these are the important questions. Ma. Voice వస్తలేదు. Hello. Hello. Am I audible to you, ma? Not you. Online people, tell me. Yeah. Able to see my screen also, right? In my childhood, I have some passion is there. Hello, 1, 2, 3, mic testing. I am doing this kind of job. 1, 2, 3, mic testing. Not proper voice. Breaking. Now, can you confirm now? Still voice is breaking? Very high. Lower your volume, no? Suresh. Very good. Thanks. Echoing. One is setting something. Let's see. Now, ma. Very good. Thanks. Thank you, Pawan. Say thanks to Pawan once again. You need to give party to Pawan before you going. Okay. Yeah, you need to respect that people, no? Generally, I lot of respect the people that doesn't I do generally. I'm not able to do some things right. Generally, I will do that. Yes. Now, give me 1 minute, ma. If I'll be late, what happen? They will feel like that I'm not to coming to office. 1 minute. Yep, we are good. So that questions are coming from Deloitte company, ma. That question they are asking Deloitte. In the Deloitte, what happened, right? The interview is not does not depend on my resume. He's asking all these questions fatafat. Okay, from starting to ending, fatafat, very fast. What is standard deviation? What is empirical rule? What is Chebyshev? What is all these things? He's asking like this. You know, maybe as a from question paper is there in front of him. He's asking very fast. All these questions. Yeah. Yeah, Deloitte, they're not offering much package. In the Cognizant, they're offering good package. That's why I go into Cognizant. No, we can't say that. How much you are expecting? How much you are thinking? More than 20, more than 30, not more than 40. Not more than 40. Ma. It's okay. Enough. That is fine. Party. Party you want? You should give the party, not me. After you got the job. Okay. Next, I need to go to the only product-based company in order to get my salary is now in saturated. I understood that. My salary is in saturated level. No one will offer more than this in the service-based companies. So, service-based companies. So, we need to jump into product-based companies. That what happens if you go to product-based company means I can't spend this much time for trainings. I can. I don't think so. That is. So that's why I'm worrying to not applying for product-based companies. Yeah, let's see now. So shall we add now here? 31, what is the concept, ma? Empirical rule. Empirical rule. And what is 32-1? Chebyshev inequality. Chebyshev inequality. Now let's come to here now. Now, whatever we do, the data analysis is very, very important to feed the good data. Feed the good data to ML model. To ML model. If you feed the good data, then your result will be good. If you not feed the good data, your result will be bad, generally. So how you train your kid? If you train your kid with good words, he will use good words only. If you train with bad words, he will use bad words only. Right, Money? That is general. So that's why, now what happened, people will, now parents are very concerned about the people right now. So one of my kid is there, okay, he used so much bad words. And who is the fault of that? Grandparents. The grandparents' fault, that is. Because grandparents will talk generally, our parents is okay, but our grandparents, they will generally, that is the habitude, right? That's it. So that's why feed the good data is very, very important to either is a kid or is the ML model. Now let's think about this. Age is there and your salary is there and your experience is there. Your age is generally in terms of which units, ma? Years. It is in terms of years. And general salary is which term, ma? It's of currency, right? It is a kind of a currency. Currency. And experience also in terms of years only. It also in terms of years. Now age is equal to 30 years. Suppose salary is equal to 50,000. And experience is equal to suppose 5 years. And age is equal to 31. You might draw suppose 1 lakh. That is equal to experience is equal to suppose some 7 years, like that is there. Now there are this how many dimensions of data this is? How many dimensions of data? How many dimensions of data? Dimensions is a 3. Okay, how many columns are there? That many dimensions. Don't forget this. How many columns are there? That many dimensions. I concern very much because I went to some college. They're already in second term in the data science, but they don't know meaning of the dimensions of the data. Okay, so you should not be like that. How many dimensions are there? That many columns are there. Okay, how can you know? Make a point. Make a point more. Write one point. How can you write the point? 30, 50,000, 5. This is the first point. This is the first point. What is the second point? 31, 1 lakh, and 7. This is the second point. How many points are there? Now 2 points are there. If you want to draw 2 points on the graph, which dimensions you will take? 2 dimensions. X-axis, Y-axis. If now what happened? X-axis, Y-axis, Z-axis. Like that, how many columns are there? That many dimensions. That many dimensions. Now here, if you see, now there is a one logic is 30 is a very less value, 50,000 is a very huge value. Again, 5 is a very less value. Why this, deviation is there? Why this deviation is there? One value is very low, one value is very high. Can't we make this all the values under the same roof? Can't we make under the values in the same layer? Same layer. And that technique is called data standardization techniques. Data standardization. Data standardization techniques. Data standardization techniques. The main goal of data standardization techniques is to make all the values under one roof. To make all the values under one layer. All the values under one layer. To make all the values under one layer. All the values under the one layer. This is a very, very important. What is the one layer? I will tell you. Now there are two techniques are there. One is called jet standardization. Jet standardization. Jet standardization. That is nothing but a jet score. Nothing but a jet score. Jet standardization. And the second one is called normalization. Normalization. That is called min-max scalar. Min-max scalar. Jet standardization and min-max scalar. Jet standardization and min-max scalar. Today I will take more often Orma. I will finish the statistics part 1 today only. And tomorrow onwards we'll do Python. TDA. Okay. In half an hour we can finish the concepts. Jet standardization and min-max scalar. Now let's talk about the jet standardization. In order to know about jet standardization, we need to know about our empirical rules. We need to know about the empirical rules. Now mu minus 1 sigma. Mu minus 1 sigma. Take that. Mu minus 1 sigma is equal to some x point. Some x point. Just rearrange, get the one value. How do you get the one value from this? How to get the one value from this? Tell me. 1 equal to mu minus x. Mu minus x, that is equal to 1 sigma. 1 sigma. 1 sigma. Now 1 equal to. Now 1 equal to. So 1 equal to mu minus x by sigma. 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 That is called 1 equal to. From mu minus x by sigma, that is equal to 1. In the similarly, if you want to minus 1 also, what will happen? X minus mu by sigma. Correct? X minus mu by sigma. Understand the formula. Take a pen and book. Just try to do like this. Now, mu minus 1 sigma is equal to some x point. How much is ma? X1 point. Now 1 equal to, how you are writing 1 equal to? Mu minus x1 by sigma. Correct? Mu minus x1 by sigma. And one more thing also, you can convert this also. X1 minus mu by sigma also. X1 minus mu by sigma is equal to minus 1. Is equal to minus 1. Both are same. Both are same. Just minus sign is different. That minus sign is different. Now here, for 2 also same answer. For 2 also same answer. Any changes? For 2 also same answer or not? Mu minus 2 sigma is equal to, again, x2 point. What happened? X2 minus mu, again same formula. For 3 also same. For 1, 2, for 3, all the formula is same. All the formula is same. And that is formula called Z formula. Z. What the formula is called? Z. Z is equal to x minus mu by sigma. What is the formula? Ma? Z is equal to This is called Z score. The Z score equal to x minus mu by sigma. X minus mean by standard deviation. That is called Z. Now onwards, Z is equal to x minus mu by sigma. You need to remember this. And you know that easily, right? Mu minus 1 sigma plus 1 sigma is the empirical rule, you know. From empirical rule, what we found? Z score. Now how many afraid about the formula of normal deviation formula? Normal distribution formula? Tell me. 2 pi sigma square e power minus x minus mu by sigma is nothing but Z only. Z square. That's it. I told you, right? Today this formula will be easy. That is called e power minus Z square. That is the formula. That's it. E power minus Z. And yesterday we discussed e power minus x means what happened? It is a exponential. Something is going like this, coming like this. What is the formula kind of? E power minus x. E power minus x is nothing but what now? Z. Z is nothing but what now? X minus mu by sigma. Over formula. No need to by heart. So Z score, what is the formula of Z score? X minus mu by sigma. X minus mu by sigma. X minus mu by sigma. This is called Z score. Very, very important interview question, ma. You can take anything. If Z is equal to 1 will come, x minus mu. Z is equal to minus 1 will come, minus thing will come. So now I will tell you here. Original data is minus infinity to infinity. Generally, correct? Original data from where to where, ma? Minus infinity to infinity. Now this is the original real axis. This is what, ma? Real axis. Now these real axis having huge values, we don't want to work with huge values. That's why we are changing the values. We are changing the values from which range to which range? Minus 3 to 3. Minus 3 to 3. Minus 3, minus 2, minus 1, 0, 1, 2, 3. And this is called Z line. What is called, ma? Z line. So real line we are converting into which line, ma? Z line. By using which formula? Z is equal to x minus mu by sigma. That is the formula. That means suppose 50,000 is there here. That value will convert into what? Minus 3. And another value will convert into what? Minus 2. Another value will convert into what? Minus 1. In real axis, the values are from minus infinity to infinity. But Z axis, the values are from minus 3 to 3. Because that is proved from the empirical rule. What is the empirical rule? Maximum. Mu minus 3 sigma to mu plus 3 sigma, 99.7% of data. So maximum minus 3 to 3. So that is called Z line. So we are just converting a one real line to Z line. So here you might be 100 kgs, but in moon you might be only how many kgs? By 6. That means you are just converting. We are just converting the values, and that is called standardization. That is called standardization. What is the standardization technique we are using here? Z score. What is the formula of Z score? X minus mu by sigma, which means suppose take one here, Z value, age equal to and age transform value. Now age, this is a age general value. This is age after transformation to Z. After transformation to Z. And this is 30. And this is 31. This is 32. Now what is the mean of, what is the formula? What is the formula, ma? X minus mean mu by standard deviation. Correct? Now X means what is the observation? 30. Minus what is the mean? 31. What is the standard deviation? 1. So what is the answer? Minus 1 by 1, how much? Minus 1. So 30 converted into which value? Minus 1. Originally 30 value. Now in the new real axis, what is the value? Minus 1. Now 31 is converted into which value? 0. 31 converted into 0. Now 32 will convert it into plus 1. The plus 1. Now the 30, 31, 32 here. The 30, 31, 32. So here exactly what will be there, ma? 31 will be there. Here what will be there? 30 will be there. Here what will be there? 32 will be there. This is the originally age. This is the originally age data. And this is age transformed to Z data. Age transformed to Z data. Not only age, if you take the salary also, that is equal 50,000, that is equal suppose 75,000, and that is equal to 1 lakh. Again, the salary Zs also, pakka values between -3 to 3. Pakka, agree with me? What happened? 50k minus 75k divided by 25k. Assume that. So minus 25k divided by 25k, the value is called how much? -1. Now all the column values now under only -3 to 3. All the column value. Before all the column values, what happened? Some are very less value, some are very high value. Now we are converting all the column values between -3 to 3 range only. So that is the idea of the standardization. Understood, everyone? Can you please confirm the chat? Can you please confirm the chat? Utkarsh is good, Shravan is good, Suresh is good, Arun is good, Shoaib, Uma. What happened others? Don't sleep, ma. You can sleep in afternoon. Okay, with full of fan speed and one nice dupatta. Okay. Yesterday I felt that. I put my laptop aside, I just slept for 2 hours. That is full of fan speed and just nice dupatta. So this is whatever the columns, we are just converting into new real axis, that all the values between -3 to 3. Now your salary year range is, here is what happened? 50,000. Your salary range how much, ma? 50k. That is a huge value. Now here what happens? 1 lakh. Here what happened? Some suppose 25k. Assume that 25k. Whatever it is. Now these values are these values also will update into -3 to 3. So that is the idea. Jet standardization. That means before standardization, values has different levels. Some might be very high, some might be very low. Some column values very high, some column values very low. But when you standardize, when you Jet standardize, all the values between -3 to 3 range only. -3 to 3 range only. All the column values, every column, all the column values. That means all the columns have values under one layer now. All the column values under one layer. Outlayers. Correct? Suresh? -3 to 3 it will fall. Then not nothing but a outliers. If it fall less than -3 or more than 3, that is nothing but a outlier. That's why outliers are Q3 plus 3 into IQR. The 3. Now every time 3 is coming, right? 3, 3, 3. That is -3, 2 through 3. That is called outliers. So now generally in original data, you might find, this is very, very important, ma. You might find some outliers. Now the question, ask yourself, is that outliers is really influential? Is that outliers really influential? What is by influential meaning, ma'am? Some outliers might be influential, some outliers might not be influential. That means it might not be affect your data. Okay, some outliers affect your data. Some outliers might not affect your data. Some outliers might not affect your data. In order to know that which are influential, which are not influential, in order to know that which are influential, we need to standardize the data. We need to standardize the data. Again, we need to find outliers for the new transformed data. Correct. Before it might be 30, 31, 32. But after what happened? -3 to 3 only, right? Again, you need to find the outlier analysis. On the transformed data. If both indexes of data, indexes means what happened? Suppose in original data, 100th observation is outlier. The value is nothing but suppose 20,000. And in transformed data, the same 100th observation coming as outlier, then this 100th observation is called influential observation. Then this 100th observation is called influential outlier. Understand, my everyone? First, we found the outlier analysis. 100 observation is coming as the outlier. In the transformed data also, the same 100 observation is coming outlier, means both times it is valid. So it is a very, very influential outlier. Sometimes what happen? This 100 observation might not coming as outlier in the transformed data. That means it is not influential. It is very, very important concept, ma. This concept especially. So recently one of our old student from USA, she got this question. Okay. She messaged me, what is influential outlier, sir? What is influential outlier? Very, very important concept is. Now, suppose you come here. This is your original data set, ma. Suppose original data set. You have indexes will be there for the data sets, right? Suppose this is 100 observation. 100 observation is called 20,000 is the value. How much value? 20,000. Now you transform into Z transformation. When you transform Z transformation, what happen? This value is only -3 to 3, correct? -3 to 3. This value might be 3.5. This value become what happen, ma? 3.5. So 3.5 is nothing but what? Outlier. Both times it is valid as the outlier. Then this 100 observation is called influential outlier. 100 observation is called influential outlier. It might be fall only 2.8 only, suppose. The value is coming 2.8 only. 2.8 is not a outlier. Here it is outlier, but here is not a outlier. You might be rich in Zimbabwe, but you might not be rich in India. Understand? You're getting? So when you transform the data, your categories also will be varying. Ambani is anywhere rich. Okay. That's why he's outlier. But what about others? I might be rich in Kuwait. Okay. 1 rupee is equal to 5 rupees. But here I might be middle class family. So like that you need to understand. So now Ambani is a very influential guy, not me. So like that, this is called influential outlier concept. Very, very important. Influential outlier. Influential outlier concept. Influential outlier. Understood, ma? Can you please confirm the chat? Influential outlier. Then outliers are there. How to treat outliers? How to treat? We already know this, right? How to treat outliers. If outliers percentage take less than 2%, less than 2%, then you can remove the outlier. You can remove the outlier. Yeah, less than 2%. Less than 2% of number of observations. Remove the outliers. Suppose data has total 100 observations. In that two observations are outliers. Then remove that. Remove those two observations. Remove those two observations. Remove those two observations. How to treat the outliers? If it is more than 2%, if it is more than 2%, don't remove. Do not remove. Okay. Do not remove. Simply replace those outliers with median value, because median does not affect, right? Median does not affect, or replace with Q3 value or Q1 value. Replace those who are more than Q3. Replace with those who are more than Q3. Replace with Q3. Similarly, those who are less than Q1, replace with Q1, those values less than Q1. Replace with Q3, those values more than Q3. So this is one option. This is one option. And this is another option. Now what is the third option, ma? If you remove all outliers, then data will be reduced, and less data, not enough to train ML model, then use data augmentation technique. Data augmentation technique. Very good. So all are important interview questions, ma. Interviewer will play. No, you should play with interviewer now, because I have delivered all the statistics concepts. That is. Next. This is how to treat the outliers. What is outliers? Influential outliers. How to treat the outliers. Okay, influential outliers concept is the Z standardization. Z score. X minus mu by sigma. And that related to empirical rule. Mu minus 1 sigma to mu plus 1 sigma. Everything is interlinked. Right? The formula, empirical rule, and the Z score and everything. Next, ma. For Z score, for Z data, the mean always 0. Standard deviation always 1, ma. Whatever the Z data, this is pakka. You need to quick check after you standardize the data. The mean should be 0. Standard deviation should be 1. This is very, very important. For the Z data, mean always 0 and standard deviation should be 1. And the data lies between -3 to 3. Between -3 to 3. Always 0 and mean is 0 and standard deviation equal to 1, ma. It is fixed. For any Z data, whenever you convert, if you apply the mean of that entire data, that will be 0. If you find the standard deviation, that should be 1. Because you see here, our formula is equal to, Z is equal to X minus mu by sigma. Okay. That means X value, you substitute this. That corresponding mean value, the value is equal to 0. X equal to mu, suppose. Mu minus mu, how much? 0. Mu minus equal to 0. For any data, the mean equal to mu. For Z data, the mean equal to 0. The mean equal to how much, ma? 0. When you transform into Z data, if you calculate mean, the mean value how much? 0. That we need to check. That is a quick check. Then only it is transformed correctly. Next one is normalization. Next one is what happened? Normalization. Normalization means the formula equal to X minus X minimum by X max minus X minimum. The new data nu x equal to the x old observation, x minimum value, x minimum value, x minimum into x max minus x minimum. X minimum forget about this. X minus x minimum. The formula, note on this formula. Like jet formula, like that, maximum and minimum formula. X max minus x minimum. X max minus x minimum. These are new x. And all the values below 1 only. Below 1 only. That's why it is called normalized. When normal, what is the normalization meaning? Everything under the 1. Everything under the 1 is called normalized. All the values below 1. Below 1. Pakka below 1. All the values. You take currency, you take kilometer, you take age, you take experience, you take salary. If you convert into normalization, all the values between 1 only. That's why it's everything values will be under the one roof. Under the... No, not like that. It is only below 1. Okay. It might be 0 or might be minus values also. Below 1 only. Only below 1. Not more than 1. Not more than 1. All the values below 1. All the values are below 1. And that is called normalization. So standardization, we have two techniques. One is called Z-score. Another one is called normalization. And this is called min-max scalar. What will be? Min-max scalar. In the standardization, Z-score. In the normalization, min-max scalar. X minus x minimum by x maximum by x minimum. Suppose if you take here 30. 30 is there, 31 is there, 32 is there. What is the minimum value? 30. What is the maximum value? 32, right? Now, first observation equal to 30 minus minimum equal to 30 only divided by maximum, x maximum minus 32 minus 30. The value equal to 0. Minimum value equal to 0 and maximum value equal to 1. Minimum value equal to 0, maximum value equal to 1. In the rare cases, it will go to less than 0 also. That will see the rare cases. But that's why directly don't judge that. Some people will say that the minimum value in the new data, minimum value equal to what happened now? 0. Maximum value equal to what happened? 1. Pakka 1 will come. So that's why the normalized data range equal to 0 to 1. That generally you will study in textbooks. 0 to 1. Like -3 to 3, Z data. 0 to 1, normalized data. 0 to 1. Maximum value को 1 आता ना. 32, x minimum 30, 32 minus 30. Maximum means 1 will come. For minimum value will become 0, maximum value become 1. In the original data, maximum value become is 1. That is the maximum. That's everything will be between the below 1, right? Below 1 means below maximum value in the original data. Like that. Understood, ma? Can you please confirm the chat? Minimum observation. The original data, if you draw, how can you draw? 30, 31, 32. How can you draw? If I ask you to on the real line, 31, 32, how you will draw? 30 is the minimum. 32 is the maximum. 31 is the between, right? In the same way, new line will what happen? 0 to 1. All the values between the 0 to 1. 0 to 1. Yeah, in some cases it will come. I will show you that is a special case. Okay, we have some data set is there. We will deal with that. Okay, some data sets is there. Yeah, that's all today, ma. Okay. Amma, sir is left now. Okay, still one more concept is there that we'll see tomorrow. And tomorrow only we'll start the Python. Tomorrow we'll start the Python. One more concept is there. But this all 30 or 35 observation, 35 points, ma. This is very, very important. Okay, this is only your EDA part 1, ma. And most of the question they will ask you in this only. If you perfect this all 35 or 40 bullet points, then you will get easily apply for data analyst jobs. Because my students perfect in Python. I have some confidence. At least you are doing something on Python. Okay, now you know statistics concepts also. Now if you learn SQL, Power BI, anyone can learn SQL, anyone can learn Power BI. That is not a rocket science. Then you can easily apply for data analyst jobs. That is. So I hope the concept, only the thing is Python and EDA is the important. Python and EDA is the important. Thank you, ma. Thank you so much. See you tomorrow.